Function transformations. First, we're going to need some definitions here. We're going to state a periodic function is one that repeats itself over and over and over again. So we have some section of the graph, and that section of the graph is just going to be copied side by side. The formal definition is f of x plus p equals f of x, where p is the period of f. The smallest p is called the fundamental period. What happens after when we say, once you start getting used to it, you say find the period, what we're really talking about is find the fundamental period. The amplitude is 1/2 the vertical distance between the max and the min. Well, how do you find the vertical distance between the max and min? That's just going to be the max minus the min. So in other words, it is 1/2 of the max minus the min. And when we're doing this, we're talking about the max value, or in other words, the y value, the f value. So let's take a look at this example. We have a picture here, find the period. What this means is we're going to have to find what is this section of the graph that if we took that section and we copied it over and over again, will create this whole graph. Now, I didn't draw this part, and we'll add this in just a second. So kind of as we're going through this, where do I end up with this same kind of relative spot where I'm going the down one, up one? And that'd be right here. So I could say it is in between -2 to 2. What if I started here though? I could do that same thing, although this graph looks like it's a little off. It should be coming over here. I'll fix that. That would be the same thing from 2 to 6, or from -2 to 2, and so our period would be 4. So the period is a length, x length, or along the x-axis of how long it takes for this thing to repeat. I can start copying this over, going in the other direction. This would be going up 2, down 2, and then down 1, up 1, and it just repeats over and over. What's the amplitude? Well, what is the max here? The max is 2. The min is -1. So the amplitude is going to be 1/2 of 2 minus -1, or 3 over 2. Now, what do you notice about this graph, f of 45? We want to find f of 45, since this repeats every 4 units. So we could also have started right here at the origin and going up 2, down 1, up 1, up 2, down 1, up 1. So if I say f of 0, that's going to be the exact same value, y value, as f of 4. What will that also be? If I go one more period, that'd be f of 8. If I go one more period, that'd be f of 12. Have we ever done anything that repeats itself every 4 like that? Remember, I to the 5th is the same as I to the 1st, or I to the 4th is 1. Any multiple of 4 is going to be 1. So what we're going to do here is we're going to take this and we're going to say 45 divided by 4, and we'll get 11 with the remainder 1. So what I'm going to have you do is write it like this: equals f of 4 times 11 plus 1. Now what does this mean, 4 times 11? 4 is our period, and it means we're going to go through our period 11 times. 1, 2, 3, 4, 5, 6, blah, 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 11. So when we stop there, it's going to be as if we were still at the origin. So this is going to be the same as saying f of 1, and f of 1 is 2. Similarly, we can do the same thing on the other side. We can go, but this time we're going to say 4 times negative 11 minus 1. Why is it negative 11? Because instead of going in the positive direction, we're going to go in the negative direction. So negative 4 will be the same as negative 8, etc. And we'll keep on going, and that will end up at a point that has the same y value as the origin. So this will be equal to f of negative 1. And what is f of negative 1? We'd go look at our graph. Well, that one is negative 1. Now, just to kind of go over it, you could say something like this. You could say f of 48 minus 45. Now, where did I get 48? 48 would be 12 periods. Because remember, all those periods are going to be the same. And so this would be equivalent to f of 3. And what is f of 3? 1, 2, 3, go down. That's also negative 1. What's the difference between negative 1 and 3? That's 4. That is our periods. And that's going to tell us, since we go back to our definition, f of x plus the period equals f of x. If we add the period in, we're going to get the exact same value. Let's take a look at how to transform some graphs. So we're going to look at f of x plus 2 and f of 2, or f of x, f of the quantity x plus 2, and then f of x plus 2. So let's take a look for right now, and let's look at some values. I'm going to plug in some numbers. Let's go 0, 1, 2, 3. Let's see what happens with this. If I plug in 0 in for x, I will get f of 0 plus 2, which is f of 2. If I plug in 1, I get f of 1 plus 2, which is f of 3, f of 2 plus 2, which is f of 4, f of 3 plus 2, which is f of 5, and I could also take a look here at f for 4, f of 4 plus 2, so f of 6. So now I can take a look at my graph up here. What is f of 2? F of 2 is 0, f of 3 is negative 1, f of 4 is 0, f of 5 is 2, and f of 6 is 0. So what is this doing? This is taking the values here that were at 2, because that's what we have here. We're taking this f of 2 value, and we're going to be moving it. Instead of having it at an x value of 2, we're going to have it at an x value of 0. Instead of having this x value at 3, it's going to be associated with 1. This 4 is going to be associated with the 2, 5 is associated with 3, and 6 is going with the 4. So let's plot these points. So 0 is 0, 1 is negative 1, and then 0, and then 2. So what happened to the graph there? Now in this one, it's not 100% clear just because I shifted it over 2 units. Oh, I didn't plot it up here. When I have these x values, I'm using these ones. So I'm taking my original ones, and I'm going to put them with something that's 2 units smaller. And now I can copy some of this other part as well, and we could also think about what would happen if I was looking at something like this, x plus 2 quantity squared. What does that do to the graph? Where's the vertex? This is going to shift it 2 units in what direction? It's going to go to the left. Let's take a look at this one. We'll use those same values, 0, 1, 2, 3, 4. This time it'll say f of 0 plus 2, f of 1 plus 2, f of 2 plus 2, f of 3 plus 2, f of 4 plus 2. So f of 0 is, looking at the graph again, f of 0 is 0, so 0 plus 2 is 2. F of 1 is 2, so 2 plus 2 is 4. 0 plus 2, negative 1 plus 2, and then 0 plus 2. Let's plot these points. 0 is going to be at 2, 1 is at 4, and then 2, 1. What happened to the original graph to get this one? And we can also, since it's periodic, we're just going to keep on going. A little bit off there, but that's okay. What happened to this graph? We took the whole graph and it was moved 2 units up. If we think about this graph, what does that do to the graph? It takes my x squared graph and it moves it up 2. That's what's happening to this. Now let's take a look at why is this one shifting it 2 units left, but this one shifts it 2 units up. This is affecting the x values. The key number when you're dealing with an x is 0. So what number would I have to plug into this in order to get me my 0? Actually, it doesn't have it right there. I would have to plug in -2. If I plugged in -2 there, it would be f of -2 plus 2, which would be f of 0. So in order to get 0 inside, in order to get to my kind of the origin type of point, the starting point, I would need to plug in -2. Over here, what is 2 affecting? It's affecting the y value. Remember, f of x is our y value, so it says take my old y value and add 2 to it. So it's going to take all those values, add 2, so it shifts everything up. Let's take a look at the next one. I'm going to refer back to that graph again. We'll just go 0, 1, 2, 3, 4 again. So we have 2 times f of 0, 2 times f of 1, 2 times f of 2. Now right now I'm writing all this stuff out just to emphasize it. As a general rule, what I want to do is look for the pattern there, so we don't need to make a table like this every single time. That would be too time consuming and a waste of our time. F of 0 is 0, so 2 times 0 is 0. F of 1 is 2, 2 times 2 is 4. F of 2 is 0, so that gives us 0 again. F of 3 is -1, so that's -2. And f of 4 is 0, so this would be 0. Again, remember I'm referring back to our original graph above. So now let's plot these points. We have 0, 4, 0, -2, 0. What happened to the graph this time? And we can continue this on. Etc. This time the y values were multiplied by 2. See what this says? It says 2 times f of x. F of x is our y value, so we're doubling all our y values. It's stretching it out. Let's take a look at this next one. 0, 1, 2, 3, 4. So f of 2 times 0, or f of 0, and that's just 0. F of 2 times 1, or f of 2, and that's 0. F of 4, 0. F of 6 is 0. So is this graph just y equals 0? No, what do you think we should look at? Let's look at some numbers in between here. F of 1/2. 2 times 1/2 would be 1. What is f of 1? That's our 2. Go back to the original one. 3/2. F of 2 times 3/2 would be f of 3. So f of 3 in this case would be -1. Let's see about plotting these now. It says that every integer value is just going to be at, seems to be at 0, and it will be. And then at 1/2 it goes up to 2, and at 3/2 it goes down to -1. What happened to this graph? And we could continue it. It got shrunk down instead of, let's see if I can, Remember, this is our original graph. And now it got squeezed down. What happened precisely to these numbers? This number here was over here at 2, and now it's at 1. The number at 3 is now at 3/2. What we're doing is all these values, all these x numbers are being shrunk down. What happened to the y numbers? The y numbers are still the same. They're still going to 2, -1, 0, 2, 0, -1, 0. But the x values are all half. Let's take a look at this and see why. The key number, again, we're dealing with the x here. The key number is 1 for multiplication. What number would I plug in here to give me 1? It would be 1/2. So what we're doing is multiplying the x numbers by 1/2. We can write that over here. On this one we were multiplying the y numbers by 2. For the y, what you see is what you get, and part of it is because of how the format of writing the equation. So now let's take a look at this. How does the a affect the graph? Well, what it's going to do is a is going to stretch it. Now, we didn't deal with any negatives, and we've dealt with negatives before. If it was a negative number like -2, that would reflect it about the x-axis. So let's just talk for right this moment. We'll just apply the positive idea. If this number is greater than 1, what it's going to do is stretch the graph vertically. What if it was less than 1? And we could add in greater than 0. In this case, since it's absolute value, we don't really have to have it. What it's going to do is shrink the graph vertically. And then, just as a review, if a is less than 0, what it's going to do is reflect the graph about the x-axis. Next piece, how does the b reflect it? And that goes back to part C, or no, this right up here, the f of 2x. If b is greater than 1, what is that going to do? That's going to be multiply the x numbers by what number? What would I plug into bx in order to get 1? I'd have to plug in, what do I plug in for the x value? I'd have to plug in 1 over b. We're going to multiply those by 1 over b, and what this is going to do is, you could say either shrink or compress horizontally, because we're affecting the x numbers here. What if we were multiplying by, and it said f of 1/2 x? What number would I plug in for x to get the value that I want of 1? When I'm looking at multiplication, I'd plug in 2. So what that's going to do is it's going to stretch it horizontally. And this is probably the easier kind. When you say f of x minus h, how does the h affect the graph? Well, that is going to shift it. Again, we're dealing with the x. So what would I plug in here to give me a 0? And that would be going to do is shift it h units horizontally. Now, as a review, if it says x minus 2, then it's going to shift it 2 units to the right. If it says x plus 2, that's going to be 2 units to the left, just like what the work we've done with parabolas. And how does the k affect it? It's taking our y values and it adds it k. So what this is going to do is shift k units vertically. Get to talking about apply all of these, to do each piece by itself and think, okay, we're going to do that, and then a is going to multiply the y values, and then we'll add k, and then we'll multiply the x values by 1 over b, and then add h. Multiplication in this case, when we're dealing with our transformations, the multiplication will come first.